Okay, so now I'm just gonna make like a. I tried recording the conceptual part, but I accidentally forgot to like record the audio. So what I'll do is I will explain everything conceptually first, like all the functions, the brute force, the optimal, and the better approach, and then at the very end it will at the second part of the video will have the coding part, the runtime analysis, and all that kind of good stuff. So I'm just gonna rush through this, but at the same time maintain like like you can still understand it. So first approach, which is the brute approach, uh let's let's say our array one. Okay, let me first, sorry, I'm kind of rushing, but let me just explain what the problem is asking us, right? So given two arrays, let's call it array one, let's call it 1 3 5 7, and then array 2, let's call it 4 5, and then 6, and then 7. What we have to do is we have to print out the values that essentially exist in both the arrays, right? So for example, in this array it would be 3, I mean sorry, it would be 5 and then 7, right? So the brute force solution is pretty simple. Let's write it out. So array 1 is equals to 1 3 5 7, and then array 2 is 4 5 6 7. So what I'll do is I will do a nested loop. So I will for each iteration of I will loop through this whole array and check if array at the ith position exists in this array. So it will be just for I till length 1, for j till length 2. So this is like of length 1, and this is of length 2. If a1 at the ith position is equals to a2 at the jth position, print them out, right? So that's pretty simple. For each iteration of I, loop through this whole array, check if this exists in this array, does not, increment my I, right? Then 3 does not exist, increment my I. For 5, I will check does not exist, 4 is not equal to 5. Here it is, print it out, and then break, and then move my I tracker. Then it is a 7, does not, print this out, okay? So that's the brute approach. And then the runtime is just length 1 times length 2, and it is because for each iteration of I'm looping through this whole array. Each iteration of I'm looping through this whole array. Each iteration of looping through this whole array. So that's the brute force solution. The optim or the better solution is essentially like, let's say we have array 1, array 2, 1 3 5 7, 4 5 6 7. Now what I'll do is I'll create a hash array big enough, like it would be like a very large array essentially. So let's say 0 1 2 3 4 5 6, then 7, right? Big enough is gonna be like, if let's just make it like a size of 1,000. I will loop through this whole array, and I will mark the index. Like, so for example, the value here is 1. Oh sorry, first things first, I will use calc to, because to fill this array with all zeros, right? My hash array will be, essentially I will use calc, and it will, as you know, in calc it will create the array and initialize each and every element to like 0. Now what I'll do is I will loop through array 1, then I will mark each element at the index. So for example, 1 I will mark here, 3 I will mark 1 here, 5 I will mark 1 here, and then 7 I will mark 1 here, right? So our hash array will look something like this: 0 1 2 3 4 5 6 7. So our hash array will look like 0 1 0 1 0 1 0. Wait. Oh, 3 does not exist in both of the arrays, sorry. So it'll be 0 and then 1 here. Now, again, I will loop through this whole array, and I'll check if this value is marked in this array, right? So 4 is not marked, right? 4 is not marked. 5 is marked, print it out. 6 is not marked, don't print it out. 7 is marked, print it out, right? The coding part would like better help you better understand how we do that in the if statement. But that's like the logical part, the conceptual part of this problem. Now the optimal solution, we will use the two tracker approach, which is a1 is equals to 1 3 5 7, and then a2 is 4 5 6 and then 7. We will have our two trackers, let's call it I, oh my god, I here and j here. What we'll do is we're essentially want to loop through this whole arrays until one of my tracker goes out of bounds, right? So we just while I is smaller than length 1 and j is smaller than length 2 and why I'm doing this is because if at any point like any of my tracker goes out of bounds, I will no longer have an array to compare with, right? So I'll just end my function at that point. With that being said, now we will have our first if block, which will be like if array at the ith position matches my array at the jth position, print them out. That's not the case. And then so we'll say if a1 matches a2, print, right? Otherwise else if a1 is smaller than a2, increment my I by 1. And why is that? Because I know for a fact that the array is sorted. So if these two indexes do not match, I can just move it here, right? And then I'll check again if a1 at I is smaller or so first thing, and then sorry, else the opposite of this would be is a1 is bigger than a2, then I will increment my j, right? So let's do a dry run. Let me show you a dry run example. Sorry, I'm kind of like rushing through this because 1 3 5 7 4 5 6 7, I is here, j is here. Okay, I and j, they do not match, and I is smaller than my j, right? I increment by 1. I again is smaller than my j, I increment by 1. Now my j is smaller than my I, increment j by 1. Now I'm at this position, right? They match, print them, right? Now once I print them, I increment them by 1, right? Because I've already found the matching values, I increment both of them by 1. J is smaller than my I, increment j, right? Now they match, print them out, and then I plus plus and then j plus plus. Now they're both out of bounds, our while loop will exit, and then we have essentially printed out 5 and 7. I've explained it more a little bit more in depth in the coding part, and the runtime analysis is in the very end. But yeah, that's like the whole like ordeal of this type of question, like sorted list matching problem. So yeah, hopefully you were able to understand.
I'm gonna write the brute force solution as we discussed. So I have like already shown you how it will look conceptually. Now for the coding part, I'm just coding it using my IDE. So I can show you the code works perfectly fine. But I would highly recommend that uh, you practice this code by writing it down. So that way, when you're like going for your quiz, you're able to like you don't have any like because writing code is it's its own skill anyways, right? So with that being said, so let's just do int slmp and we'll call it the brute force solution. It will take in two arrays, int a1, right? And then it would take int a2, then it would take the length of these two arrays, so we'll just call it int len1 and then int len2, right? So that's pretty much makes sense. So a1 len1, a2 len2, or sorry, it should be a void function because I'm not really like returning anything. I'm just like printing out which values are found matching, right? So let's just do this. So for int I equal to 0, I is smaller than len1, which is the length of array 1, I plus plus. Then I will for each iteration of I will have a j loop. So for int j equal to 0, j is smaller than len2, j plus plus. Then we'll have our conditional here that essentially will check if the elements at these position match or not. So we'll just say if a1 at the ith position equals to a2 at the jth position, printf the number %d exists in both the arrays, and then we'll have our we can print out either or, right? It doesn't really matter. I'm just gonna print out a1 at the add position. Once I'm done, I'm gonna break out of this loop because I found the value, and I'm no longer wanting to like loop again and again, right? So for example, so what would happen is anytime you will find a value that matches, this inside J loop will break, and then and this loop, the I will go to the next index, and it will keep going until we have like ran out of the length of the arrays essentially. And the time complexity. Okay, so how about this? I'll explain all this, and at the very end, when I'm done writing all the code, I will briefly explain the time complexity of each method here, which is like the brute, better, and the optimal. So that way you can just like maybe you can like skip to the last part and then go through it. Part of the optimal approach. Let's call it void slmp. Sorry, not the optimal, but the better approach. Again, we will have our same parameters, int a1, int a2, which is an array. Then we have int length 1, and then int length 2. And now the first thing I will do, I will create enough space for my hash array. So let's make it 1,000 because in my test case, my hash array is not my array 1 and array 2 are not going to be too big. So I'll just make it of size like 1,000. So again, think as in the conceptual part, I told you like think of a function that we can use to create memory and fill and initialize all the values to 0. The function that comes to mind is calc, right? So what I'll do, int star hash equals to calc, and then calc takes in 2 arguments. First, like how many space that you want, and what would be the size of each space essentially. So let's do 1,000 and then size of integer, right? And then what I'll do is now I will loop through my array 1. So for int I equal to 0, I is smaller than len1, I plus plus. Now I will mark hash at position a1 at I, right, equals to 1. So that's the part where we're like marking. So hash at position array 1 at the ith position. So and that will mark it as 1. So that's the marking part. I'll write a comment, something like marking part is here. Now once we have done that, we will loop through our array 2, and I will check if this value is marked as 1 in my hash array, and if it is, then I'll just like print it out. So for int j equal to 0, j is smaller than len2, j plus plus, then I will say hash if hash at position a2 at j equals to 1, equals to 1, printf the number %d exists in both the arrays n, and I will just print out like a2 at the jth position, right? Hopefully that made sense. This is a little tricky part, but like this is kind of tricky obviously, but if you solve enough questions using the concept of hash arrays, you'll kind of like start to recognize the pattern. Something that you might find tricky is like this part, but this part is essentially going, so think of hash at position a1 at the ith position, so it will go to each element of the array 1 at the ith position and then mark it as 1 in my hash array. And this part is essentially doing the same. It's saying like if hash at position a2 at position a2 at the jth position equals to 1, then print it out essentially. So this sometimes people find it tricky, but once you do a couple of dry runs, I hope it makes sense to you. And if it not, you can always visit my office hours. Coding part, I'll just do slmp optimal, and then we will have our int a1, right? Int a2, and then obviously we will have our lengths, int length1, and then int length2. Now what I'll do, I'll initialize my tracker. So int I equal to 0, and then int j also equal to 0, right? Now I will have my while loop that will check if my I tracker is inbounds and my j tracker is inbounds. I think I forgot to mention this, but think of this: if at any point my I tracker goes out of bounds, I know for a fact that I did not find values that were similar in the both arrays, and then my I tracker has essentially gone out of bounds, so I have no longer to check anything, right? So while I is smaller than len1 and j is smaller than len2, so this will like essentially keep track of if my I tracker or my j tracker are going at any point going out of bounds, and if they're going out of bounds, I immediately stop because I have no longer do anything to compare for, right? So first things first, we'll do if if a1 at the ith position matches a2 at the jth position, printf, right? I'll printf these the number %d exists in both the arrays \n, and then it would be just, I can print either or, it doesn't really matter. So I'll just do a1 at the ith position. Again, doesn't really matter which one you print, but you can print a2 at the jth position. Once we have done that, we have to increment both of our trackers. So it will be I, because we have found the matching values, right? I plus plus and then j plus plus. And then otherwise, if a1, so let's say a1 at the ith position is smaller than a2 at the jth position, right? I would increment my I tracker, right? So for example, if the if the value at array 1 is 1 and the value at array 2 is 3, I would obviously have to move my I tracker, right? Because the value is less essentially. So I plus plus, and then the else block would be j plus plus. This is essentially just saying else if a1 at I is bigger than a2 at j. That's essentially what it's saying. And then yeah, that's pretty much it. It's giving me some error. Oh, semicolon, my bad. But again, try writing these codes in pen and paper, so that way you have like a better, like you can during the time of the quiz you can clearly understand. So now let me just write out the main function, int main, right? So now we will do we will have our integer arrays. Oh, also I forgot one thing. We need to, in this function, we would need to like free our hash array, right? So free hash. So just do that, so that way we do not have like any memory leaks. So let's do this. So let's do int array1 equals to 1 3 5 7, sorry, 5 7, and then int array2 equals to what was it, 3, sorry, it was 4 5 6 7, and then we will create the length part, right? So it will be int length1 equals to size of array1 divided by size of array1 at position 0. So that way we'll get the whole length of the array. And then int length2 equals to size of array2 divided by size of array2 at the 0th position. And then we have two lengths because in some scenarios the length of array1 and the length 2 will not match. So that, right? So I'm just going to printf the actually I'm not gonna actually let's do this. Printf this, let's call it brute, and then we'll just call the function in so it would be just, our function would be slmp brute. We'll give it our array1, array2, and then length1, and then length2. Then printf better slmp optimal, sorry, better array1, array2, length1, and then length2. Again, printf optimal, and then we'll call slmp optimal. We will give array1, array2, len1, len2, and then return 0. Okay, what is the errors? Printf. Okay. Like fix the main function. Now I'm just gonna test it. GCC slmp.c out as slmp, and then we will do slmp. I mean, it works, just the formatting is like terrible. It works fine, but you can try fixing the formatting, but it works perfectly fine. So now for the time complexity. So the first one is just order of length 1 times length 2, because what we're doing is for each iteration of I, we are traversing to the whole array of array 2, right, which is of length 2. So it just like becomes length 1 times length 2, because each iteration in the array of size length 1, I'm going through the second array, which is of length 2. So it's just like length 1 times length 2. This one again is just the better approach is a length 1 plus length 2. Why? Because look at this, right? First, I am traversing through the length 1, which is the array 1. Then I'm marking my hash array. Then I am traversing through my array 2, which is of length 2, right? And then I am traversing through it and then checking if if the array at that position is marked in my hash array, and then printing it out. So it's just pretty simple, length 1 plus length 2. Now for the optimal one, this is kind of a little bit trickier, on not too tricky, but so let's just say there were, so we always in the runtime scenario, unless it is specified, you kind of always have to give the worst case runtime, right, which is like the upper bound. That is what like runtime usually represents, unless it says in the question that, hey, I want you to tell the best case runtime of the given function. But usually if it doesn't say, we always give the worst case, right? So in this, think of the worst case. In this scenario, let's say array 1 and array 2, they do not have any matching values. So what will happen is we will traverse through the whole array 1 and then array 2. So essentially it just becomes the same as length 1 plus length 2. But this function is overall better than this function here, because we're creating all this extra memory for hash array, which is of size 1000. So like this kind of like, we're using all this extra space, when in reality we can just solve the problem using this method. So hopefully that was easy to understand. If you had any more questions, you can comment them down, and I can try to explain them better. Thank you.